The Earth. A giant mass of rock and water flying through space. It's unlike any other planet we know because it supports life. It's not just our home. It's the only safe haven we have in the universe. But how did it get here? What strange forces of nature created this living, breathing planet we depend on? It's a mystery scientists are only now beginning to solve. Naked Science brings together the latest research to discover just what it took to create an Earth on which people could live. In this vast cosmos, there is only one place we know where humans can survive. It seems as if the Earth was made for us. It supplies us with water to drink, food to eat, and air to breathe. It's the only home we have, and we rely on it entirely. But 5 billion years ago, it did not exist. Where the Earth now sits in the outer reaches of the Milky Way galaxy, there was just a large cloud of gas and dust. This is the astonishing story of what transformed that cloud of dust into the planet we know today. One person who understands what it takes to build a planet is astronomer Tom Fleming. Using telescopes like these at Kitt Peak in southern Arizona, astronomers have pieced together how the Earth was born.
It all begins with a big cloud of gas and dust, little particles of dirty stuff, grains of sand, grains of silicon.
Scientists call these regions of dust and gas molecular clouds. But they're not like any clouds we see on Earth.
Molecular clouds are vast. They cover hundreds of light years in size.
It was from clouds like these, photographed by the Hubble Space Telescope, that the Earth formed. The clouds are made up from the debris of hundreds of dead stars. The large molecular cloud had a small rotation. When it shrank, this rotation speeded up. As the cloud contracted, the energy of the material flying in from space caused its center to heat up. This spinning ball became our sun. The rest of the cloud was spinning so fast that it spread out into a vast disk of dust and gas. This was the cradle of life, the material that would form the Earth and all the other planets. Until recently, what turned this dust into a planet was a mystery. Then, in March 2003, a lighthearted experiment on board the International Space Station led to a significant discovery. Astronaut Don Pettit was curious to see the effects of weightlessness on different substances. In a series of simple experiments, he filmed bubbles, indigestion tablets, swirls of colored water, then filled the plastic bag with salt. This last experiment turned out to be a scientific revelation. But at the time, Pettit didn't realize its significance. The person who worked out what it meant was fellow astronaut Stanley Love.
Don likes to mess with things, and one of the things he messed with was putting things in plastic bags, granular solids like sugar, salt, instant coffee, He put them in a bag, inflated the bag, and shook them up just to see what would happen. And what happened was the little particles formed up into clumps like dust bunnies instantly.
When he saw a video of the experiment, Love realized that he was witnessing a significant discovery.
And Don shot this video down. He said, "This is cool, isn't this neat?" And showed all his little videos and his different substances and the different bags. And I said, "Don, yeah, that is neat. Actually, you've solved a very old problem in planet formation."
In zero gravity, the crystals behaved completely differently to the way they behave on Earth. Love recognized what was making them stick together.
Well, anytime two different materials rub together, you can have a few electrons get traded off from one material to another. This happens when you rub a rubber balloon on your hair and stick it to the wall. As it turns out, once you get dust or basically anything in zero gravity and shake it up, let it bump into each other, we think it gets some sort of electrostatic charge on it, which makes it clump up together just immediately. You can break up the clumps by shaking the bag up, and then they reform as soon as you stop shaking it.
In the first few seconds of its life, our Earth may have looked something like this. Scientists think that this moment occurred 4.5 billion years ago. To follow the evolution of our planet, naked science is going to represent the time from then to the present as 12 hours on the face of a clock. At noon, the clock started ticking. The Earth's journey toward becoming a planet that can support life has begun. The first step didn't take long. Once clumps of these particles had grown into objects about 1/2 mile in diameter, their mass was great enough for their gravitational pull to attract material from the surrounding disk. Like giant vacuum cleaners, they circled the sun, sucking in material from the disk until there was nothing left to consume. In the inner solar system, these clumps grew into around 20 planets. This process took about 3 million years. Less than 30 seconds on our clock. The next stage of the Earth's evolution was incredibly violent. As these 20 planets orbited the sun, their gravity affected each other, and they began to collide. With each collision, 2 planets combined. Over time, these collisions reduced the inner solar system to just a few planets, including Venus, Mercury, Mars, and Earth. Astronomers believe that the Earth grew to this stage in around 30 million years. We are now just 5 minutes into our story. But what was early Earth like? What would happen if a human had landed here? The energy from the collisions with other planets made the Earth incredibly hot. At around 8,500 degrees Fahrenheit, its temperature is more than 5 times that inside a cremation furnace. A human would almost instantly disappear in a puff of steam and ash. But even as our planet cools down, another danger threatens. A storm of charged particles is approaching the young Earth. It's so intense that it could end all chance of life. 4.5 billion years ago, a giant cloud of dust collapsed to form our solar system, the sun, planets, and Earth. But as the newly formed Earth began to cool, it faced one of the biggest threats to its existence: a hurricane of deadly particles from the sun. Boulder, Colorado. At the Space Environment Center, meteorologists monitor the storms on the sun. It's the most extreme weather you're likely to see. A light breeze out there is 200 miles per second. and a low temperature is 8,000 degrees Fahrenheit. Around-the-clock surveillance is necessary because storms on the sun affect us here on Earth. Space scientist Rodney Viereck knows just how deadly the sun can be.
The sun is a large explosion, and from that explosion, energetic particles are released.
These particles make up the solar wind, and they travel toward Earth at speeds of up to 1 million miles an hour. If the solar wind becomes too strong, it can kill.
We watch the sun, and when we see something that may produce energetic particle events here at Earth, we try and warn astronauts, even airlines, about these types of events.
The charged particles in the solar wind are a form of radiation that can cause lethal damage to living cells. An intense solar storm could kill an astronaut caught in space. But the solar wind can also have a devastating effect on planets. The Earth is surrounded by an atmosphere, a thin layer of gases that protects it from the extreme temperatures of outer space. But when the charged particles in the solar wind hit a planet's atmosphere, they can strip it away. You can see how destructive the wind can be by looking at Mars. Over millions of years, the solar wind has blown away most of its atmosphere. Now there is no liquid water on the surface,